All right, today we are solving one-step algebraic equations, specifically equations that involve multiplication. Let's get to it. Let's say we have the following problem, 7x equals 98. Now, just a reminder that when we are approaching these one-step algebraic equations, we have one initial goal, which is to isolate the variable. In this case, the variable is x, and the variable represents the unknown and is represented by a letter of the alphabet. So it could be X, Y, Z, A, B, C, whatever. But it's a letter that represents the unknown. And by isolating it, we want it to be alone on one side of the equation. And what that means is we want it on one side of the equal sign, which means it could be to the right or to the left. We want it to be alone on one side of that. So 7x equals 98. Just a reminder, when we have a number next to a letter, it means to multiply. So if you sometimes forget that a number next to a letter means multiplication, if you want, you can always, put that number in parentheses. I always write my sevens like that and with the line across, but I don't want to confuse you guys, so I'm trying to not do it like that. If it helps to do it that way, write it that way, then go right ahead. But just know that a number next to a letter means that the number is being multiplied by the variable. So back to the equation, we've got 7x equals 98. Our goal is to isolate the variable, which means we want to make it all by itself, all alone on one side of the equal sign. And so we start by applying the inverse operation to multiplication. So in my class, we've done one-step equations with addition and subtraction. We know addition is the inverse of subtraction, and subtraction is the inverse of addition. Well, it works the same way with multiplication and division. Multiplication is the inverse of division, and division is the inverse operation of multiplication. So in the case of 7x equals 98, we are going to, because these numbers, we want x to be alone, and to get rid of the 7, we need to apply the inverse operation to multiplication, which is division. And so what we're going to do is we are going to divide both sides by 7, because we want to cancel out that 7 here so that we can get x to be alone. So 7 over 7, the reason that this will cancel out is because 7 over 7 equals 1. Remember, any number divided by itself is 1. And then 1, which means if I have 7 over 7 times x, it's the same as 1x, which is the same as x. And so that allows us to have x alone. So let me cross out the 7s. And now we're left with x equals 98 divided, let me go back a step, 98 sevens. And that is actually the same. Remember that this division bar is that this fraction bar is the same as a division sign. X equals 98 divided by 7. And now I'm going to use standard algorithm long division to solve the division problem. And it looks like I have no remainders. And my answer is 14. X equals 14. And I always encourage my students to check, do a double check the problem to make sure they didn't make any mistakes. So our original equation is 7x equals 98. If x is 14, it would mean that 7 times 14 equals 98. And so let's make sure we didn't make any mistakes. 7 times 4 is 28. 7 times 1 is 7 plus 2 is 9. It checks. It checks. So that is one example of a one-step equation involving multiplication. Let's do another one that looks different. What if I have the following problem? X over 4 equals 28. Now, I have students who will look at this problem and incorrectly assume that x equals 7. Why? It's because they know their multiplication facts really well, and they assume that x just has to be 7 because then you would have whole numbers in the equation that are all somehow linked. No. We got to go through the steps because x is not 7. That would be the wrong answer. So let's get to it. So here we have x divided by 4. Remember, the fraction bar represents a division. It represents division. So if we are using division, we have to apply the inverse operation, which is multiplication. We need to multiply both sides by 4. And remember, this dot means to multiply. And then what happens when I do that is the 4's cancel each other out. It becomes 4/4 times x equals 28 times 4. 4 over 4 is the same as saying 1x equals 28 times 4, and 1x is the same as x, because any number times 1 is itself. And now we can solve by multiplying 28 times 4. 4 times 8 is 32. 4 times 2 is 8 plus 3 is 11. And that means x equals 112. I hope I didn't go through that too quickly. And I want to just comment about this, that some students get confused as to why when I multiply 4 by x over 4, why these cancel each other out. And so if we want to get into a deeper understanding of it, let me show it to you this way. X over 4, let me write out the equation again. X over 4 equals 28. Another way to think about multiplying x over 4 by applying multiplication is you're doing x over 4 times, we're going to multiply both sides by 4, which is the same as 4 over 1. It's 4 over 1. Suppose I didn't really need to do it that way, but I want to make it clear. And now, remember, because of the commutative property of multiplication, which means you can switch numbers around and that are being multiplied next to each other, what this means is we have x over 4 times 4 over 1 here, which can be rewritten as 4x over 4 times 1, which is the same as 4x over 4, because 4 times 1 is 4. And these cancel each other out. Or another way to think about it is 4 over 4 times x over 1, and these cancel each other out. So I hope that wasn't confusing. Let's do a couple more examples. Let's do this example. X over 3 equals 17. All right, let's get to it. Well, here I'm dividing, so I need to apply the inverse operation. I need to multiply. What am I going to multiply by? I'm going to multiply both sides by 3. You could think of it as 3 or 3 over 1. I'm going to multiply both sides by 3. If it helps to do it that way, I can do it that way. These cancel each other out. I'm left with x over 1. And any number divided by 1 is itself. So really what I'm left with is x. X equals 17 times 3. Let's do that out. 3 times 7 is 21. I'm going to add 2 in the next column. 3 times 1 is 3. Add 2, and that is 51. So x equals 51. Another way, if I want to check it, I can say 51 divided by 3 equals 17. If it checks, then I'm right. I already checked it, so it does work. And so that's how you would do that. Let's do another one. What if I have a problem that looks like this. 1/4 x equals 28. All right. Well, what we're going to do is here we need to get rid of the 1/4. So one way, and I haven't really explained this, but I'll try to now. To get rid of it, we can multiply by 4. Or another way to think about it is 4/1, which is the reciprocal of 1/4. And so I'm going to multiply that, also multiply that by 4/1. Okay. Now, 4/1 times 1/4, those cancel each other out, and I'm left with x equals 28/1, which is 28, times 4/1, which is 4. What is 28 times 4? And I'm realizing, did I do this one already? Shoot, I did this one already. I'm doing the same problem. Well, we'll do it out. X equals 112. Let me do 1. Oh no, this is different. Wait, where? 1/4 x. Okay. It is the same problem, just written differently. Let's just do 2 more problems real quick if you still feel a little confused. Let's do the problem 4x equals 48. Now, since I am multiplying 4 by x, I'm going to apply division, which is the inverse operation, to multiplication. I'm going to divide both sides by 4. 4 and 4 cancel each other out. I'm left with x equals 48/4. X equals 48 divided by 4. I happen to know that 48 divided by 4 equals 12, and x equals 12. There's my answer. Okay, let's do one more. Let's do this problem. X/7 equals 32. Last problem, let's do it. And I am dividing by 7 here, so I'm going to apply the inverse operation and multiply by 7. So I'm going to multiply both sides by 7. The 7's cancel each other out. I'm left with x equals 32 times 7. Now, what is 32 times 7? 7 times 2, that's 14. Going to add 1 to the next column. 7 times 3 is 21. I'm going to add 1, that's 22, and x equals 224. There's my answer. So I hope that was helpful, and we're going to be working on it a lot in my group, in my class anyway. And remember, practice is what makes progress. And until next time,